Hello future engineers and my dear students, welcome back to Mudassir Academy, your final destination to make engineering mathematics easier, clear and more interesting. In today's video, we will learn one of the most important methods in linear algebra for the VTU Engineering Mathematics-I syllabus, that is the Gauss Elimination Method. The Gauss Elimination Method is used to solve system of non-homogeneous equations. So, before learning this method, it is essential to understand the concept of row transformation and reducing the given matrix to echelon form. And that we have already done in the previous video, that is finding the rank of the matrix. Okay, and that I have explained in a very beautiful and simple way. So, if you haven't watched that video yet, then please go check it out. And if you already know how to find the rank of the matrix, then also request you to go check it out first. Because trust me, it's something different, it's my method. Now, as we already discussed, Gauss elimination method is used to find or solve a system of non-homogeneous equations. So, let's make it very simple here as I always do. So, please pay attention to the theory part. Okay, it will be easier for you to solve the problems further. Now, let me write a system of non-homogeneous equations. Let's take a11x1 plus a12x2 plus a13x3 equals say a. Okay, a21x1 plus a22x2 plus a23x3 is equal to say b, and a31x1 plus a32x2 plus a33x3 is equal to c. So, this is a system of non-homogeneous equation. So, we can also represent this as Ax equals B, where A is the matrix of all the numbers A11, A12, A13, A21, A22, A23, A31, A32, A3 so on, and X is the matrix column for all the variables for which you have to find a solution of using Gauss elimination method. Those are x1, x2, x3, or it may be x, y, z so on. Okay, and B is the right side, it is a constant. Now, the Gauss elimination method in a very simple form, how to solve, it is a method. So, simple. First what we write a matrix called as augmented matrix. See, augmented. Okay. So, the augmented matrix is written as A augment B or semicolon B equals to, see how I write this. Augment meaning in very simple way something extra attached to or something extended to. So, here the general matrix A we write it as A11, A12, A13, A21, A22 and A23, and the last row A31, A32, A33. Now, this is a matrix A. Okay. Now, what we do here to augment this, we extend this matrix by adding this ABC constants. So, semicolon A, semicolon B, and this is C. Now, this is called as augmented matrix A augment B. Now, what we do here is very simple. We have learned the method of row transformation. In that, we take this as the first column, first person, in my method husband, second column, second husband, third husband. Now, what we do, making use of this, okay, we make this and this both equal to what? 0, making use of this. Fine. And making use of this, we make this equal to 0, making use of this. That's all. 3 by 3 matrix. Okay. That is what? We make first A31, then there is a step for row transformation or reducing to echelon form. A31, then A210 making use of A11, second column is A22, we make A320 making use of A22. See, we get all these elements down below that lower triangle elements as 0. Now, making this all lower triangle elements 0 and finding the value of x1, x2, x3 is called as Gauss elimination method, making all below terms 0. That's it. This is called as Gauss elimination. That is, the turn part below the principal diagonal elements are all 0. Eliminate them. By doing that, we can easily find a solution for, see, this is for x1, x2 and x3. So here you can see, you can easily find when this all 3 become 0, we can easily find x3 from this. Put here in second row, find x2, put here in first row, find x1. That's how Gauss elimination method works. So we'll make it more and more simple by solving a problem. So once you pay attention how it is done, and once you're able to understand one problem, you can solve as many problems as you can with ease. So please pay close attention how I solve the system of equation using Gauss elimination method in the problems ahead. Okay. So let's start with the problem here now. So before starting with the problem, I thank you all for your likes, your comments and a share. Believe me, these are all acting like an alternate chemo for me during my treatment. So please keep motivating me, keep subscribing, keep sharing the videos with the friends and classmates as much as possible, and please don't forget to subscribe. So moving on with the problem, we have solved by Gauss elimination method. 2x1 plus x2 plus 4x3 is equal to 12. 4x1 plus 11x2 minus x3 is equal to 33, and 8x1 minus 3x2 plus 2x3 is equal to 20. So this is a system of non-homogeneous equation. We need to solve it. That means we are going to find here the value of x1, x2, x3. So they may also give x, y, z. So let's solve this question here. Now please focus on how I am solving it. If you miss any part, then it's your own risk. Okay, and after the end of this video, I assure you that if you stay with me, you will be able to solve any problem given from any textbook with ease. It's my guarantee. And also one more thing, see, I am receiving many comments from students, asking that are these videos applicable for 25 schemes on? Yes, definitely. See, these are, I'm making this in today's date. These are freshly made videos, and they are 100% applicable to all VTU 17, 18, 21, 22 and the present 25th scheme. Okay, and 150% applicable to the present 25th scheme. So you can also explore my YouTube channel for the playlist and organized courses according to the subject codes, like 18 18 Mat 11, 21 Mat 11, and there are some codes like BMAT S101, BMAT C101, BMAT M101, or the fresh recent syllabus, that is one BMAT S101, so on. Fine. And now let's begin the problem here. So first what we do, as according to theory, the Gauss elimination method is a very simple method. Okay, and the classic method, first we find the augment matrix. We take the augment matrix as A augment, that's A semicolon B is equal to, we write this matrix as the augmented matrix. See here carefully. First all the coefficients of x1, x2, x3, so on, that comprises the matrix A here. So we have 2, 1, 4 and 4, 11 and minus 1. Be careful while taking down this matrix from here. If you miss any sign or any numerical value, then you will get some answer, but that will be wrong. Okay, so 8, be careful here, 8 minus 3 and 2. Now the extended augment matrix is nothing but you add the constants to it, semicolon, 12, then we have 33 and we have 20. So we have the augmented matrix A augment B here. So as we know, this is row 1, row 2 and row 3. Okay. So what's the concept here? As we discussed, we use the method of row transformation to bring it down to echelon form. What is the echelon form? We making use of this 2, we make this and 4 and 8 0, making use of 11, we make minus 3 0. That means below the principal diagonal, all the elements should be 0. Okay. Then we will be able to easily solve or obtain the solution for x1, x2, x3. So let's see how we do it. Now, first, what's the concept here? My method, what I told, husband and wife, this is first husband, 2 wives. We need to make this first below, go from down, 8 then 4 equal to 0, making use of 2. So first we will make 8 0, making use of 2. Please pay close attention. You are going to make first 8 0, making use of 2. How can we make this 0? 8, if this 2 was 0, then obviously 8 minus 8 0. Simple. So what I will make? I will make 2 as 8. So what is the LCM? 8. So multiply by 4 to the 8, 4. Okay, the first row multiply by 4. So 4 to the 8, write it above here. I am making this simple for you. If you follow this method, then you will get the accurate answer. Okay. So 4 to the 8, 4 to the 4, 4 to the 16 and 4 to the 48. So we will be using this above row, that is 8, 4, 16 48 for our operations now. So what is the operation here now? To make this 80, R3 minus 4 R1. So let's write this process. A augment B equals, now as I told you, in any matrix by row transformation method, when a row is multiplied by any number, any scalar, it remains the same. So as I told you, we use 8, 4, 16, 48. This will remain as it is. Be careful here. 2, 1, 4, 12. Now 4, and we have 11 minus 1 and 33. Now see here. 8 minus 8. See this 8 minus this 8. 3 minus 4. 2 minus 16. 20 minus 48. So 8 minus 8 is 0. Minus 3 minus 4. Be careful. Minus 3 minus 4 will add. It will become minus 7. Next we have 2 minus 16 is minus 14. Then we have 20 minus 48 is minus 28. Done. Okay. Now the next thing is this 0. Done. Now making use of this 2, we have to make this 4 0. Below this 2, both should be 0. Correct? No. Now how to do it? Again, this is 4, this is 2. How can I make 4 0 make use of 2? If this is also 4, obviously it's 0, 4 minus 4 0. So multiply the first row by again 2. The same as 4. 2 2s are 4, 2 1s are 2, 2 4s are 8, and 2 12s are 24. So the operation is R2. We have R2 minus 2 R1. Okay, so let's do this operation here now. So 4 minus 4, 11 minus 2, minus 1 minus 8, and 33 minus 24. So right here, A augment B equals, what's it? The matrix 2 1 4 12 as it is. We'll be using the top what I written here, 4 to 8 24 for operations, and this is as it is, colon 12, then 4 minus 4 0, 11 minus 2 is 9, minus 1 minus 8 will be minus 9, minus 1 minus 8 minus 9, 33 minus 24 will be 9 again, and lastly we have 0, minus 7, minus 14, and minus 28 as it is. Now again I write this as A semicolon or A augment B equals, see what I told you while solving previous problems and all, focus on the matrix, have your vision clear. See, try to make things smaller because I am dealing here with whole numbers, correct? For you to get exact answer, if you deal with fractions, your mind gets confused. So whole numbers are plain. That's why try to make things smaller. So in row transformation, the row can be multiplied divided by the same number. If it is, see here, 9 minus 9 9, it's divisible by 9. So I'll divide this whole row by what? 9. And see here, 7, 14, 28, they're all divisible by 7. So divide by 7. Let this the matrix, the numeric values reduces and our operation becomes simple. So we have this as now, see, 2 1 4 12 0, 9 ones are 9, 9 ones are 9, 9 ones are 9, 0, 7 ones are 7, 7 twos are 14, 7 fours are 28. Beautiful. So easy. Now lastly, below this 2, 0, done. Now below this 1, this minus 1 should be 0. That means making use of this work is over now. First has been 2i. Now second column, second entry, making use of this, you have to make minus 1 0. And it's so simple. Why? Because making use of 1, I have to make minus 1 0. Obviously, minus and plus means operation is add. Minus 1 plus 1 0. So the operation is R3 plus R2. So we have A augment B, A semicolon B is equal to now 2 1 4 12 0 1 minus 1 1 0. Minus 1 plus 1 is what? 0. Minus 2 minus 1, minus 2 plus minus 1, minus 2, 2 plus 1 3, minus minus, so it will minus 3. And lastly minus 4 plus 1 is also minus 3. That's it. So our work is done here. See, all this I made 0. This is called as what? Gauss elimination. From below, making all zeros called as Gauss elimination. Done. And now as you see here, these are all the values for this column is for x1, this for x2, and this is for x3. Getting it? This for x1 right here, x1, x2, and x3. So how to find the solution now? See, very simple. If you go according to rows, see, as I told you, this for x1, x2, x3. Fine, simple. First, go from down. 0x1 plus 0x2 minus 3x3 is equal to minus 3. So we have minus 3x3 equals minus 3. So what is x3 is equal to? 1. That's it. So what is x3 is equal to now? We got 1. Fine. Similarly, let's say the second row. See, 0x1, see, for this x1, 0x1, x2 into 1, x1. So it is what? x2, sorry, x2 into 1, x2, minus x3, minus 1 x3. So minus 1 x3 is equal to 1. Okay. So matrix itself represents a system of equations. Fine. Now x2 minus 1 is equal to 1. So what is x2 is equal to? 1. Take this side, 1 plus 1 is 2. That's all. So x2 is equal to 2. And lastly, put in the first row. See, x1, x2, x3. System of equations, 2x1 plus x2 plus 4x3 equals to 12. So 2x1 equals to 12 minus x2 minus 4x3. So that is 12 minus, what is x2? 2. What is x3? 1 minus 4. So 12 minus 2 is 10. 10 minus 12 minus 2 is 10. 10 minus 4 is 6. So 2x1 is 6. So x1 is equal to 3. That's all. x1 is equal to 3. So you found a value of x1 as 3, x2 as 2, and x3 as 1 using the Gauss elimination method. So I write by Gauss elimination. So I'll better write here. So by Gauss elimination method, by Gauss elimination method, we have x1 is equal to 3 and x2 is equal to how much? 2, and finally x3 is equal to 1. That's all. So these are the values by Gauss elimination method. That's it. As easy as that. Now see, if you want to, now sometimes what happen now, sometimes this is very simple question, okay, but whatever simple will be, it is easy if you verify it. So if you verify and find the answer to be 100% correct, then definitely you are sure that you are going to get full 6 to 7 marks. I show that using calculator. So I have my FX 991 C1W here. I am using this because latest syllabus, using latest calculator, you can solve in any other also. That is simple actually. So we have here on, we go to home, then we go to equations. We are solving for simultaneous equations here, simultaneous. x1, x2, x3, number of unknowns is 3. We put all the values, 2, execute 1, execute 4, execute 12, execute 4, execute 11, execute minus 1, execute 33, and this row 8, execute minus 3, execute 2, execute 20. That's all. So when you press execute, we get x as 3, that is x1, 3, right? Then y, it is x2, s2, and lastly we get z, x plus 1. That's it, as simple as that. So 100% guarantee answer is correct, and 100% guarantee you get full 6 to 7 marks. That's it. Okay. So that's all for today's video. I hope you clearly understood and 100% understood how to use the Gauss elimination to solve a system of non-homogeneous equations. So if you have any other comments and queries, or if you want me to solve any other problems of matrices or any other topics, so please post in the comment below. See, this is very easy. So merely watching this and scrolling ahead will not help you at all. So please, you see the same problem, practice along with me, okay, 2 to 3 times, then you refer other textbooks, practice those questions, or from the question papers practice those questions, and if verify using the calculator, if the answers are correct, then that will boost your confidence and you become more and more confident. See, I put all my efforts in teaching you, so it's time now to put your efforts now to become successful in engineering mathematics. So keep practicing, keep more and more practicing, keep moving forward. See you in the next video. Bye.